This podcast is brought to you by the IIEA, sharing ideas, shaping policy.
Hello and welcome to the Institute of International and European Affairs. Today we're discussing sustainability of the aviation sector, a sector that has enjoyed explosive growth for decades, and there's absolutely no reason to think that it won't continue to enjoy explosive growth in the years ahead as the global middle class increases. And despite all the talk of de-globalization, there's still a lot of globalization going on. People are going to want to travel for business, for pleasure, etc. So the challenge for the industry is how to make sure that that increased demand doesn't add to global emissions, and that's what we're going to discuss today. Before introducing the speakers, let me introduce the chair of our Climate and Energy group here at the IIEA, Fergal McNamara, who's going to give a very brief introduction. Fergal.
Thank you very much, Dan. Good afternoon, ladies and gentlemen, members of the Institute. My name is Fergal McNamara, and I'm an energy specialist at the stockbroker Davy, but in my spare time, I do chair the Climate and Energy group here at the Institute. And I won't take up too much of your time this afternoon, but just to say two things, really. First of all, this talk is going to be one of a series that we're planning to organise on the sustainable aviation and the sustainable maritime. The topic of Ireland's connectivity is very important to us, of course. And the second thing is to add my thanks to the three speakers who have come along this afternoon to give us this talk. Stephen Fitzgerald from Ryanair, Stephen Gillard from Boeing, and Professor Marina Efthymiou. Professor, thank you very much, Dan.
So I also like to welcome the audience online. These days we have multiples of people online as we do in the room, but of course welcome to everyone here who's attending in person. So without further ado, each of the speakers is going to present for about 7 minutes, and then we'll have plenty of time for a discussion. So might we start with you, Stephen Fitzgerald?
Oh, I think it's me.
You, sorry. Sorry, Steve. Oh, Steve, it's getting mixed up there.
So first of all, thank you for having us here today. It's an honor to be here. And what I'm going to do is really try and outline the vision for how do we see that the industry gets to net zero 2050. And what we'll do is we'll highlight a few of the key technologies that we're going to need along the way. But I always start with this slide. And as I was mentioning to some people downstairs earlier, it's really sobering to think about that 80% of the world's population has not been on an aircraft yet. And aviation is fundamentally a force for good in the world. We connect people, we enable economic growth, and we provide high quality jobs. And you can see sort of some of the global view of that there. But also, Europe is disproportionately an aviation economy. So supporting an energy transition in aviation is key to supporting the growth of this industry, which fundamentally helps to drive GDP and prosperity, but also actually connecting cultures and societies, which is just fundamentally a good thing. Today, we're about 23,000 aircraft in the global fleet. So what does 2050 look like? Well, 2050, that number of about 4.9 billion traveling will be about 10 billion traveling. And the number of aircraft will increase to around 45,000. So we're going to roughly double air traffic and the size of the fleet over the next 25 years. And a lot of that growth is already baked in. So this is a journey we need to get right in terms of decarbonization, but also we have to grow sustainably and support the aspirations of society. At the moment, we're about 2% of global emissions, but we don't want to sort of rest on our laurels by saying, oh, it's only 2%. The reality is our share of emissions is going to increase over time, just by virtue of our growth, but also by virtue of the decarbonization of other sectors. And we are a hard to abate sector, but we're focused on how do we still meet that net zero goal. And I think as a sector, we're unique in the way that we do actually operate together and have that common shared vision. So how are we going to get there? So fundamentally, we're an aircraft company. We build aircraft and we want to continue to make those as efficient as possible. The biggest lever I have available to me right now is to modernize the fleet and get the fleet to the latest standard. It doesn't matter whether it's our aircraft or the other guys, much rather it was ours. But fundamentally, every generation of aircraft is 20 to 30% more fuel efficient than the last. And today, we're only about 30% of the global fleet being at the latest standard. So there's a lot that can be done there in terms of just turning over fleets and getting them all to the latest generation. Operational efficiency is the next pillar. So by operational efficiency, it's really how do we operate that aircraft once it's entered service? And I really look at this as almost being like a sports team, so a Formula One team or a really top level world tour cycling team. It's relentless pursuit of marginal gains. And so we'll do that through digital products. So we have a number of different products that fly on the aircraft and help the pilots to plan and optimize their routes, saving fuel along the way. But also it comes down to maintenance practices. How do we move aircraft around the airfield? What are we doing in terms of air traffic modernization? I know it's a very difficult subject, but in Europe, maybe about 10% gain there. And then lastly, how do we look at technologies we can continuously spiral into the fleet? At the top of that operational efficiency program picture, you'll see a picture of a 777, which is our current eco demonstrator. We've been flying the eco demonstrator for over a decade now with 12 different aircraft, and it's a flying laboratory. So over 200 technologies have been tested on there, and about 30% have made their way onto the fleet, and the rest we've learned a lot from, but really looking for those critical little improvements we can make throughout the system. Then we look at renewable energy. I'll talk a little bit about this in a minute, but essentially 3 choices: SAF, electric, and hydrogen. SAF is the technology which is the biggest opportunity we have between now and 2050. I can't state that strongly enough. However, we continue to look at other technologies as well. We take a SAF and approach, but SAF is critical. Advanced technologies, we're always focused on, well, what does the future hold? At the top of that, you can see a plane which looks a little bit peculiar with an orange background. That's our X-66 demonstrator that will fly in 2028. It has a transonic truss brace wing. So the trusses that come underneath the wings, and the wings are extra long and thin, are actually lifting body themselves. So that actually helps us to reduce the emissions associated with flying and increase the efficiency by about 30%. So we're going to go fly that, go test it. And let's be clear, there will always be residual emissions, we believe, in this industry. So actually, how do we take market-based measures? And we have Corsair, obviously, as an industry, but also looking to CDR as well as an opportunity there. We tried to visualize this for everybody, and if you've got a few minutes, look at cascade.boeing.com. It will bring a lot of this to life, and we developed that with a number of different knowledge partners you can see listed at the bottom of the slide. But I cannot encourage you enough to go and have a look at it, have a play with it, and it will just pull out what are the key technologies that we need and why. So SAF. We've been working on SAF for a long time now. We started back in 2008 with the first flight on a commercial aircraft, which was a Virgin Atlantic 747. And there's a nice sort of synergy to this because obviously we did the first transatlantic flight on a commercial aircraft last year on a 787. But also we've committed to have all of our aircraft capable of flying on 100% SAF by 2030. And we're doing a lot of work in that space. We flew the first commercial airplane on a test flight on 100% SAF way back in 2018. As I talked about, SAF is the critical technology. When you look at any roadmap, the majority of, or a large proportion of aviation's decarbonization journey is going to come from sustainable aviation fuel. But we need a number of different things to actually bring that to fruition. We need to grow the industry by about 1,000x from where it is today. That sounds like a lot, but it's roughly about 6% of global oil and gas capex. So it's within the realms of what we would expect to see for investment in a new type of technology. I'm not going to read those out, but what you can see is that it's a team sport. It's not just saying to the government, give us money. It's also what can we collectively do to make sure that we have robust sustainability criteria around feedstocks and that we're working with the finance industry to ensure the supply of capital for new production. And then, as I mentioned before, we're not just looking at SAF, we're always looking at the and as well. There's no silver bullet that gets you to net zero. You need to use a number of different tools. And what could they look like? Well, before we look at any new technology, we ask ourselves really a number of different questions you can see highlighted here. So is it technically possible? How many Nobel Prizes are we going to need? Are we going to need to break or bend the rules of physics? And so you look at a technology like hydrogen, and technically we could build a hydrogen aircraft given enough time, given enough resources. Today, where we are, we've flown 6 different aircraft on hydrogen. We've also built a full-size composite cryogenic linerless tank. Honestly, I swear I get given tongue twisters to use at these. And I'll show you a picture of that in a minute. The problem is then I come up to the next question. Is it safe and certifiable? Whatever I produce has to be as safe or safer than the current generation of jet-powered aircraft. of jet fuel powered aircraft. And so do I understand that? You know, we built the SLS, so the Space Launch System for the Artemis program. That was delayed several times because of hydrogen leaks. We're dealing with the smallest element. This is really, really difficult stuff. And then what's the certification basis globally? It's okay for Europe potentially to move in one direction, but we need to make sure that the FAA, Canada, Brazil, all of the regulators have a certification basis for this aircraft. And then what's the value proposition? The tanks are huge. We normally keep fuel in the wings. You can't really do that with hydrogen. It doesn't like to be compressed. So we're going to take up a lot of space. And so what does that mean in terms of passenger numbers, in terms of infrastructure? It gets very, very complicated very, very quickly. And then lastly, we're going to make the climate better or worse. That's the goal here. At the moment, we can see huge potential in renewable generation, but that's going to be needed for society and for other applications for hydrogen. But at the moment, 98% of the world's hydrogen is gray. And so if I actually, and Cascade would show that beautifully, if I actually produce a hydrogen aircraft today, I would make the problem far worse. So we need a hydrogen economy. And if we had a hydrogen economy today, I'd put it into SAF. We're flying a number of different demonstrators just to go test all these things. I've talked about some of them already, but that tank that I mentioned is down on the bottom right there. And you can see that's ice at the bottom of it. It's about 4 meters in diameter, and that's scaled for a regional aircraft. So not in a single arm. It's really, really difficult stuff. So storing something at minus 250 and then combusting it at the, at the relevant combustion temperature, that's a tricky problem. So, if I had to take away anything, if you had to take away anything from this, it's a team sport, and we need to work across industry, academia, government, and the energy sector in a way that we haven't done before. It's an exciting time. We're going to see more change than we have at any time since the dawn of the jet age, but the critical technology is SAF, and we need help to scale that.
Just one question on speed. Will these hydrogen planes slow things down or speed things up?
Every company's going to make its own decision on which way it wants to go. For us, we're focused on understanding the technology. It's important that we understand the technology, but we're laser focused on delivering things that we know can have an impact. And that's why you're seeing the investment in the X66, but primarily in actually just getting aircraft out to the fleet as quickly as possible, and then rolling in the upgrades and sort of continuous improvements that we see through programs like the Eco Demonstrator.
Right, thank you. So from Stephen from Boeing to Stephen from Ryanair.
Thank you very much. That is me. Excellent. So I'll give the airline operator's perspective on decarbonization, our journey, what we're doing, and how does the industry look at these types of things. So I'm sure many of you have flown on a Ryanair aircraft. If you haven't, this is our route network. This is our coverage. So we're flying to around 37 different countries, 233 different airports. That's our focus. We are getting market share across the board. We have plans to grow our fleet over the coming decade. We're going to get to 300 million passengers per annum from about 200 million passengers this year. We have 600 aircraft in the fleet now, and we've 350 on order with Boeing. So the newer aircraft coming into the fleet are more fuel efficient, and that's what's going to drive this growth into the future. I mean, the aviation industry has a duty to lower its contribution to global warming, and decarbonizing the industry will take a mix of different technologies. They all have the potential for reducing CO2 emissions, but tough legislative decisions are also going to be made to help drive these things. And not to sound like an echo chamber, but it will take the collective effort of all different stakeholders within the industry to make that happen. So in the broader sense, it will be the same things that Boeing have spoken about. It'll be increasing our use of sustainable aviation fuel, new technology improvements, airframe for the airframe, and also making airspace more efficient. As an airline operator, we can impact on the operations, and by flying as efficient as possible, that's our first role in this process. So when people think of Ryanair, I think that the low cost mantra comes out very much. So fuel is about 40% of our cost base. So the more efficient we fly the aircraft, the lower we can keep costs, the lower the fares will be. So that's our first focus, and these are the type of things that we look at. They're not everything that we look at. As Stephen mentioned, some of the avionics that are coming into the fore now in terms of how fast or slow you should fly the plane in terms of dynamic CI. That will have an impact in terms of fuel efficiency. But we look at dynamic flight planning systems. We get the most up-to-date weather, so the pilot knows exactly how much fuel he or she should be taking on board with each flight. We look at continuous descent approaches where ATC allows it, and where there's more congestion in airspace, you're not able to do that. Once we land, what do we do? Well, single engine taxi, turn off one of the engines. We generally get to do that on 90% of our landings. We'll be able to turn off one of the landings, or one of the engines on landing. Obviously, we're a point-to-point operator, so it's more efficient than having to go through a hub and spoke model. And then no long haul. So SAF is the key to decarbonisation. We have grand plans for SAF. So we have a target well above mandates. So the European target, European mandate is 6% SAF in 2030. The UK's is around 10% in 2030. And we plan on using 12.5% SAF. It is going to account for around a third of our decarbonisation journey out to 2050. SAF, as Steve has mentioned, it's renewable or waste-derived jet fuel. The benefits are around 80% lower greenhouse gas emissions. And by researching in it now, we hope to scale. So we have a research partnership in place with Trinity College in Dublin. They're looking at a few things. One of them is looking at the different greenhouse gas emissions of different feedstocks and their different production processes. So if you can redirect investment to the one that has the most benefit, that will obviously play a key role and help the entire industry decarbonize. The other is looking at pre-screening tools for early SAF candidates. So looking at the viscosity of different fuel types. And at the minute, it takes about 200 litres of SAF to start doing tests to see if it's a good candidate to be put into production. They can do this with just a few drops. So Trinity, through their role, have become the EASA pre-certification partner. So new SAF candidates will go through them. There's definite challenges with SAF, though. I think broadly, there's three that I think about: technological, environmental, and also commercial. So a lot of the technologies that are going to help scale SAF, they're in their infancy. So HEFA SAF is the one that's in most broad production at the minute, but there's different issues with that. There's a finite feedstock base that can be broadened in different ways, but by and large, the move has to go into second generation types of SAF and ultimately into power to liquid SAF. So the second generation SAFs are where the investment is needed now. In the UK, they're putting a cap on the type of HEFA SAF that can be produced. So I think it's around 7% of the 10% that's required in 2030 can be HEFA, and they're really pushing the second and third generation SAFs by introducing the sub-mandates at an earlier stage. So there are technological challenges there, especially on the power to liquid. In my role in Ryanair, I deal with about 30 different fuel suppliers. They're all at different stages of readiness for the mandates, but they're also at different stages on their SAF journey as well. So when I think of kind of best in class in Europe, I look at the guys in, say, Repsol in Spain. They've got a Cartagena plant, the ability to produce around 200,000 tons a year of SAF, but they also are investing in the power to liquid side as well, where they've got a test facility up in Bilbao. So the research is absolutely adapting to this. The mandate is ultimately what's making them do that. Looking at fleet renewal is another element. So as Steve has kind of given the overview on Boeing, but you need an airline on the other side to actually buy the aircraft, and that's what we're doing. So we have the game changer aircraft, which is a MAX 8 variant. It's 16% more fuel efficient, but it carries 4% more passengers. And that's what it's all about for us, really, especially in over the next 10 years. It's about fuel efficiency and CO2 efficiency. So getting more passengers on board and also lower fuel emissions. That's the journey over the short term. It gets even better when we start taking the MAX 10 aircraft. It's 20% more fuel efficient and carries even more passengers. So our CO2 intensity can be reset downwards. So already we're one of the most fuel efficient airlines in Europe. Our CO2 efficiency is about 66 grams per passenger kilometer. We plan on getting that down to just below 50 grams by 2031. And that's on the back of this aircraft order. But what we're doing now is we're still using new technology. So we're retrofitting the existing fleet with split skimmer winglets. They help with lift, and ultimately they save about 1.5% in terms of fuel savings, but also lower noise and lower NOx emissions as well. These are the climate goals. It's built on everything that I had just said. So it's about the investment in SAF, the investment in the newer aircraft as well, but also engaging with regulators on air traffic management. So we've seen through different publications on the single European airspace reform that there's the potential to save up to around 10% in terms of emissions by different measures, but more direct routings is a key one. I don't know if you flew last year at all, but ATC strikes in France, I think you counted for about 66 days. You had to avoid huge amounts of space. It obviously led to delays, but obviously flying around airspace is less efficient, so you burn more fuel. And if you could avoid scenarios like that, that would also help the industry decarbonize. So that's something that we've been pushing as well. We have a net zero by 2050 goal. And we've also submitted targets for SBTi approval. And so that hopefully will get us to our 2050 goal, which is built on those key pillars. And again, just to summarize, there seems to be a push, especially at a regulator base, to put the burden of decarbonization on European operators. So the market-based measure in terms of pricing carbon is called the ETS, and it only applies to intra-European flights. SAF mandates are applicable in Europe. They're not applicable in the US or in other regions. So the focus is very much going that way to focus on intra-European carriers. So look, I think being the best operator in that model will certainly serve as an advantage. But I think aviation decarbonization isn't an intra-European issue. It's a global issue. And if 70% of the emissions aren't being tackled through regulation, it's almost like a free pass. And that's ultimately what's happening here. Thank you very much.
The electric vehicles seem to just come out of nowhere. That technology advanced really quickly. Is there any possibility that sustainable energy fuel technology, there could be breakthroughs that would lead to the price point of sustainable energy fuels coming down to matching conventional aviation fuel?
I don't think we'll ever match conventional aviation fuel. I mean, the process for producing SAF will always need that bit more science in terms of what goes into producing it. It will need government incentives or market-based measures in order to get that price down in line with conventional fuel. And we're starting to see that. So with the ETS reform that's coming through, airlines are going to be receiving allowances where they pick up SAF, and the amount of allowances they receive will be based on the price differential between SAF and conventional aviation fuel. So they're the type of policies that we absolutely support and which will help us increase our use of SAF.
Right, thank you. So next up is Marina from Dublin City University. Could I just remind the online audience that you can get your questions in via the Q&A function, and I'll pick them up here. The sooner you get them in, the more likely they are to be put to the panel. Marina, thank you.
Great, thank you. Thank you very much, both Stevens. I think they provide some excellent examples where industry supports research. So I was given 7 minutes, so I thought to have 7 minutes plus 1 point, okay? So I will start with the first one. As we also heard from Stephen, aviation is really a very difficult to abate industry. What it's very important to note also is that if aviation doesn't do anything, then we're gonna have the revoking of the license to operate from the regulator. That is gonna be a really big mistake because it's gonna be a loss for the connectivity, economies, and people. Aviation has been the first industry that has implemented global solutions for decarbonization. We have seen significant steps over the last years with technology, sustainable aviation fuels, and a number of other measures. So I'm an academic, so I lecture. I have here some slides. I'm gonna be flying some of them and staying in some others. So that's gonna be not 1 minute per point, but anyway. So here we have the journey for the decarbonization. It's a source coming from IATA. There are different modeling behind to what extent we'll rely on SAF or carbon offsets or technology or capture storage utilization or operational and infrastructure improvements. But here is an example that is widely applicable. and used in various contexts. What we note here is that SAF is a game changer. So I'm going to be focusing a little bit more on SAF because what we see, I'm sorry, the slides weren't supposed to appear like that. The background was white, something happened. Anyway, maybe that's what happens when you're doing them very late in the night. So we are talking about SAF. Both Stevens here, they start referring to SAF extensively. It's because it's a technology of now. We are not in a situation to have hydrogen. We don't have electric. And also when we look for medium haul to long haul, 75% of the decarbonization is going to come from that because commuter flights is only 1% of the emissions, for example. So that's why we focus more on SAF. Then SAF policy. So I have been in various discussions. Technology is available. There are a number of certified pathways. What is significantly missing, what's the driving force behind all the decarbonization efforts is policy. So here we have some examples of SAF policy around the world. Europe does lead the way through the Green Deal, where we have the ReFuelEU blending mandate. Before I jump to the blending mandate, let's see also a little bit about the pathways. We need to correct some misconceptions. The use of biofuel does not provide land use changes, does not affect food prices. This type of biofuel is not categorized as sustainable. So in order to classify something as SAF, it needs to comply with a number of serious, critical, robust environmental criteria in order to lead to the decarbonization. So here we have different pathways. What is fantastic is that because the industry in the last years is doing significant steps to decarbonize, and it's taking that very seriously, and we have seen that with Ryanair giving a couple of million to Trinity and Boeing being here today and so on. So we have seen significant improvements in the technology for certification of the SAF. We see a quite wide spectrum of biomass feedstock, and we have seen also the blending units in many of those pathways being currently to 50%. Later on, it's going to be also increasing. So technology is there. Then when we talk about SAF, another misconception is that all SAF is the same. No, all SAF is not the same. So depending on the pathway, depending on the feedstock, the decarbonization journey of the SAF can be quite different. So when we're looking at which feedstock, and the industry shouldn't be feedstock agnostic, when we look at which feedstock we're using for SAF, we need to be looking also to how many CO2 can it remove during the life cycle assessment, during the whole journey from production to consumption of SAF. Then another important point, I see that there in the slides, it's very quite packed. We see there the ReFuelEU blending mandate starting from Europe. Just to make a note, initially they were thinking about 67% of SAF by 2050. The regulation became even more ambitious, so now we raised to 70% by 2050. Currently, the uptake of SAF is 0.05%. We're going to be reaching the 2% by 2025, but I don't know what will happen after 25 if the policy doesn't become more serious and scale up the production, support, even with subsidies. And when SAF can be a situation where we can increase our energy security and have an opportunity for making money as a country at the national level, because very few countries are blessed or not blessed having fossil fuel. A number of countries like Ireland, for example, can invest in renewable energy and producing sustainable aviation fuels. Okay, then I have various points there, but anyway, I'm mindful that the 70% blend by 2050 is very high. We also need to be mindful also of the penalties and what effects it might have for airlines and also at the national level for reaching the Green Deal. Okay, then at the bottom, and I have spelled it out because I'm mindful of where I am as a non-Irish person, the Inflation Reduction Act is a different approach followed by the states on the fuel. So we also need to be mindful on what kind of policy are we going? Are we going with a carrot? Are we going with a stick? And how can we create stuff that it's commercially competitive? Okay, then coming to the end, and 7+1 points I promised. What I'm also very mindful as an academic is that the mandates are largely based on the volume of SAF rather than the decarbonization potential. So I wonder, should we also be looking at agreeing that since SAF is not all the same, maybe we also need to look more closely as aircraft operators at the country level, as industry professionals, what kind of stuff are we looking at, and also be mindful of a number of scandals that they have been coming out with, maybe baptizing cooked oil in China, various biofuel. Anyway, then the last 7+1 point, and I'm going to make it a little bit more complicated here, is that the sustainable aviation is not just about CO2. We are talking about CO2 because from the IPCC Intergovernmental Panel for Climate Change report in 1999, we know for sure we have a solid scientific understanding on how long CO2 stays in the atmosphere, to what extent it contributes to climate change. For NOx, contrails, and so on, the scientific understanding is lower. But something it's certain is that the non-CO2 effects contribution of climate change is 66%, okay, significantly higher than CO2. And there, when we look at SAF, we have SAF having significant effects not only on the CO2, but also on other elements, because it will have lower aromatics. So it will have lower non-volatile particle matters, lower sulfur. But then I wonder what happens with NOx. And I mentioned NOx because the emissions trading scheme is having a revision and looking for implementing monitoring, reporting, and verification, including non-CO2 effects, also NOx. So it's something that maybe we need to also be looking at for the decarbonization, having a more systemic approach and not looking only for CO2, but also looking at how we can fight climate change. And just to highlight something, the industry is serious for fighting climate change. And we have seen that with various events that they are organized like this one. We have seen it with Boeing investing in technology, with airlines like Ryanair investing in SAF, with leasing companies looking at creating a portfolio that is sustainable, with the airports and so on. And as Stephen said, it is a team game.
This podcast is brought to you by the IIEA, sharing ideas, shaping policy.